good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Luinda with another video, differentiation. So we are on differentiation, part of calculus. This video will be about finding the gradient, alright, or finding the derivative using the gradient function from the first principle. Alright, so if this is your first time listening to such, it might be confusing, but I'll break it down to what it means. So we have a curve. Any curve, you're just given a curve like that, and then you have a particular point here, for example. Let me draw the curve better, like that. Okay, that's more like a curve. So you have a point here, we just call it x, and another point here, we call it, alright, x also, but let's know that the distance here between these 2 points is h. So this next point will be x, this x plus this h will give you the next point there, x plus h. Alright, and then the y-coordinate for this one here is the function f of x. So f of this x. Then the y-coordinate for this one is the function f of this coordinate, x plus h, like that. Since you know the when we talk about functions, the y-coordinate and the x-coordinate, the y-coordinate, of course, we represent it by the f of x. Then the x-coordinate is the f. I mean, is the what is in the bracket is the x-coordinate, right? Because we have the x there, it is in the brackets. Then the x plus h is also in the brackets. So, if you want to find the gradient function from the first principle, okay? So you know your formula, m is equal to y2 minus y1 over x2 minus x1. If we draw a secant line is just a line that is cutting the curve at 2 points. It's cutting the curve at 2 points. It's called a secant line. Okay, so this curve is passing at those 2 points that I've talked about, those 2 particular points. Okay, so this is a straight line actually. It's supposed to be more straight. So those 2 particular points. This point as a coordinate is f, comma f of x. Okay? Then here it is a x plus h, comma f of x plus h. Like that. Then, since we have drawn these 2 points like that, we want to find the gradient of these 2 points, right? The gradient of this line. Now we are finding the gradient of this line because these 2 points are along this line. So we want to find the gradient of that line. What do? Let's say this is our x2, y2. Because we came up with these points by adding this h. Then this is our x1, y1. So our m would be equal to y2 is our x plus h minus, y2 is f of x plus h, you minus y1 is f of x, right there. Then our x2 is x plus h minus our x1 is x. So if you simplify this, this would be x of f plus h minus f of x. Then this and this can go, you divide by h. So what we have done is actually we have found a certain, okay, function that can give you the derivative or the gradient. It's a gradient function. So it can give you the gradient. This function, it's a gradient function. Because we had 2 points and we found the gradient of this line using this. So this will say f prime of x is equal to f of x plus h minus f of x, like that, divided by h. And one thing to note is the limit. We always take the limit. So when we say the word limit, we just abbreviate it as lim. Let me write it here. The limit as h approaches 0. So what am I trying to say? You should know this. In additional mathematics, you are required to know, just know this. So this is called the gradient function from the first principle. This power 1 is not inverse because there's something called inverse, like that. This is f inverse of x. Now this is f. It means you are taking the first derivative. So f prime of x is equal to f of x plus h minus f of x over h at the limit as h approaches 0. So this is the formula for finding the first principle, for finding the gradient function. Okay? Finding the gradient function from the first principle. The next videos we are going to give examples of how we can find the derivative or the gradient using this function. Thank you so much for watching. This has been Cornelius Lubinda with another video, and bye bye.